The other day, I was at a library with one of my friends, and that library had a public Wi-Fi connection. But that Wi-Fi connection was very slow. It was about 20 megabit per second. So I decided to check my phone and see if I can get a better internet connection using my mobile network. My phone was actually worse, and it was around 10 megabit per second. So I asked my friend if he can check his phone and see if he can get a better connection. He was getting a better speed because he was using another provider, and his internet speed was around 35 megabit per second. So he had the best network compared to me and that library Wi-Fi. I was thinking it would be very useful if we can somehow connect all of these separate connection together and get a better and more high-speed internet. I'm sure you had this experience that you have multiple connections, like your phone, your Wi-Fi, other devices, but each individual connection is so slow and not really reliable. So if we can somehow connect them all together, we should get a more reliable internet connection. In this scenario, if I could combine all these connections together, I should get a decent connection, something around 65 megabit per second. If I could somehow connect them all together and create a new connection. I searched about this problem, and turns out there are devices that you can buy and connect other device to it, and it will get you a better internet connection. But I think we can do this without buying a new hardware. We should be able to do this with software. There should be a software out there that does this, right? Like combine different connections together. Why am I saying that? Because at the end of the day, each connection is a network interface. And we can probably control each network interface. And if we can control them, we can redirect the traffic to a new connection. I searched about this problem, hoping I can find a software to do this. I found this website called Speedify that they do exactly what we need. Right here, you can see when you open Speedify, it will recognize all the different connections you have. Like this connection is a Wi-Fi connection, this one is a mobile network connection. So it can recognize different connections, it can show you different speed for each one, and it can combine them all together. It also says that if you use multiple internet connection at the same time, you'll get a more reliable connection. That's what we thought. So I wanted to download and test this myself, see if it actually works. I downloaded Speedify on my machine and also connected my phone through USB to have multiple connection connected to my phone. You can see it right here that it recognizes my Wi-Fi and recognizes my phone connection. So Speedify is already doing what I was thinking about. If we go one step further, you can see that my Wi-Fi has a IP address 192.168.146, and my phone internet has another IP address 192.168.177.72. You might be wondering why we have two separate IP. The reason we have separate IP, as I was mentioning in the beginning, each connection is a network interface. Like the operation system, like Windows, Linux, Mac OS, they all do this. When you connect an internet connection to your devices, they recognize it as a network interface. And you have all the different network interfaces connected to your machine. And each network interface would have a different IP address. So yeah, in theory, we can just use Speedify, connect different devices to our machine, open Speedify, and then it will combine all those connections together. But I'm curious to know how they're doing it. Like how they are combining all those connections together, specifically this part of the process, how they're connecting all those connections together. What I'm thinking about is that internet is not a one-way connection. It's actually a bi-directional connection. What I mean by that is when you're using a browser or any application, or even if you're playing games, you're getting information from internet, but you're also sending out information to internet. So in one way, like this area, in this area, you're combining those connections, whereas on this area, you need to distribute out those connections. So you have to break your requests or packages and send them out to different interfaces. You see that challenge? On this part, you need to combine those connections. So you're getting different packages. You need to somehow understand and combine them. On the other hand, you have to distribute those packages. You have to break down those packages and send them out to different network interfaces. So I would like to know how they're doing these two different challenges and how they're fixing. If we can find an open source project, we can look at the code and see how they're doing it. I found this cool project on GitHub. It's called go-dispatch-proxy. What it does is it can show you all the connected interfaces you have. You can see the first step is this command, go-dispatch-proxy -list. And it returns all the connection that you have to your phone. And it will show you all the connections you have to your machine. It's the same thing that we had here. You might have one connection with IP address. You might have multiple connections with multiple different IP addresses. It can recognize them and show them to you. So that's the first step. The second step is it can combine those connections together. So it says that it will create a load balancer in a tunnel, and you can see that it's assigning different IP addresses to that load balancer. And you can see a number at the end of each IP address that it says it's a connection ratio. So the idea here is it's not breaking down each package. It's actually deciding how many of those packages should go to network interface number 1 and how many of those packages should go to network interface number 2, 3, 4, and so on. So I really like this approach because what I was thinking about was actually more complicated. I thought each package should be broken down to multiple packages and then we have to combine those packages. It was very complicated what I was thinking about. So let's try it out and see if it actually works. There are two ways that you can use this tool. One way would be to just clone the code and compile it yourself. As you can see, it's been written with Go language, so you can clone the code, compile the code, generate an executable file, and then just use it. Another way would be to use this release feature here. In the release section, we can see the executable files, so you don't have to clone the code and compile it and doing all that. You can just get the executable version here. It's very easy. As you can see, I've downloaded the exe file, the executable version. You can download the Linux version or Mac OS version. They would work the same. You just have to download it and extract it, and you can get this file. Okay, let's get back to the documentation. The first step was to get all the interfaces. Let's see if we can recognize. I'm connected to a Wi-Fi connection and a phone network connection. Yeah, it's recognizing Ethernet 3, which is probably my phone connected through USB. It has an IP address. It's also recognizing my Wi-Fi, which has a separate IP address. And these two connections, I'm not sure, they're probably for Windows subsystem Linux, which is a virtual thing. We're not going to be worried about that. So this first two are my Wi-Fi and my phone. And if you want to double check if these numbers are correct, we can go back to Speedify, go to Wi-Fi, and you can see 192, 168, 146, the exact same thing here. And if I go to my phone, 192, 168, 177, 72, exact same address. So the first step is working fine. Now, the second step is to create that tunnel, which is like a load balancer. So this is the command. We can say go-dispatch-proxy, my Wi-Fi IP. We can try different combination, different ratio. For now, I want to stick to just 50-50 connection. Like half of the requests go to Wi-Fi, half of them goes to phone network. Then we're gonna play with this ratio thing and see if we can get a higher speed if we change that. So if I want to say 50-50, I should assign same number. For instance, we can just assign 1. If I run this, you can see that it says local server started on 127.0.0.1.80.80. What this means is this new connection that we have here would be running on this address. If I want to use this new connection that we created, this new tunnel we created, I have to redirect all the traffic in my machine to go through this IP and port. If you want to do that, we can use different tools. What I'm going to do here is to use Proxyfire. On Proxyfire, you can define different firewall rule. It's like you can say any request should be redirected to this IP and port. You can define a rule in your firewall to do that. Proxyfire is an easy way to do that. You can use different apps and even go to your firewall setting directly and set that rule. I'm going to stick with Proxyfire because it's very easy to use. And right here, I can create a new role and says any connection has to go through SOCKS 5 127.0.0.1.80.80, which is the exact address that we have here. If I want to test how fast this connection is, I can use speed test. A speed test actually have a CLI version which allows you to run speed tests inside the terminal and not the website. I found this very cool because you can use this on your server. It's very easy to use. I'm gonna use the CLI version. Obviously, you can go to the website and use the website. It's pretty simple to install. It's a Python package. You can install it using pipe install. So let's see how fast our connection would be. Something interesting that's happening here while I ran this speed test CLI. One interesting thing that's happening here, you can see all the requests that is going through this new tunnel that we created. If we take a step closer, you can see the first request is going through 146, which is my Wi-Fi. The next request is going through 177.72, which is my phone. Third request is going through Wi-Fi. Fourth, going through my phone. So you can see that each request is going through a different route. And the reason they're 50-50 is because I set the ratio to 1, which basically means 50-50. It's like a queue, and each request goes through different routes. And the speed test result was my speed was 6 megabit per second. What I would like to do next is to go through the code and see exactly how this tool is working. You can see a summary of the code here. And we're gonna try and see if we can create something like Speedify, something similar to Speedify, and see if we can create an user interface for this. But since this video is taking long already, we're gonna do this on the next video. So next video, we're gonna go through the code and we're gonna see if we can create a user interface, something like Speedify, and yeah, publish it on GitHub. So there you have it. Thank you for watching. I hope I see you in the next video. Next video is going to be more like a coding video. So yeah, thank you for watching, and I will see you in the next video.